Our next presentation, ladies and gentlemen, is about 4 supercomputers twice. That is the subject, 4 supercomputers twice. This will be presented by Mr. Andrew Jones, Future HPC AI Capabilities Planning from Microsoft. Ladies and gentlemen, here is Andrew Jones.
Hello and welcome to this presentation. My name is Andrew Jones. I work on future capabilities for high-performance computing and AI as part of Microsoft Azure's corporate engineering program. I'm going to talk today about 4 supercomputers, about doing that twice, and then about what we're doing beyond that. I'll start by talking about supercomputing at Microsoft. There's 2 sides to this. So the first is that we have a significant internal usage of supercomputing infrastructure. So we've deployed HPC and AI infrastructure, genuine supercomputing infrastructure for internal use cases that span HPC workloads, AI workloads, and other use cases. So Microsoft itself is a supercomputing center, is a user of HPC. We also make some of our HPC and AI capabilities available to customers through the Azure platform. And then, of course, that gets branded as Azure HPC and AI products and services. And so Microsoft is also a provider of HPC. Like many HPC centers, in fact, are both a center and a provider, or a user and a provider. That experience with both sides of the coin in supercomputing is one of the key drivers behind Microsoft's unique approach to HPC and AI. In terms of the way we provide it to the market through Azure. We have deliberately decided to focus on providing a differentiated solution for HPC and AI. So rather than building a generic cloud capability, deploying HPC instances within that generic cloud capability, we've taken a deliberate decision to, as well as doing that for the rest of Azure, to deploy specifically HPC-focused infrastructure, HPC-focused software and infrastructure, and HPC-focused people and teams and business processes. So we have purpose-built platforms, purpose-built technology. So as well as the compute-optimized VMs with low latency networks that all of the major cloud providers have for HPC, only Azure goes beyond that and adds in InfiniBand HPC clusters, which gives you better performance, better scalability on real workloads. And then we actually deploy real supercomputers for the most demanding applications and the most specific use cases. But it's not just about the hardware, or indeed just about the software infrastructure. It's important to recognize that we are using real-world applications through benchmarking to actually plan, design, and deploy and test the infrastructure. So it's designed against real workloads, not against some theoretical abstract. And in fact, we use the same benchmarks or similar benchmarks to demonstrate the capability to our customers and to work with our customers to demonstrate how their applications actually perform on our infrastructure. But it goes beyond the application performance as well, and that's the people side of things. So we're building a genuine HPC approach, a differentiated approach around the people side of things. So for example, we are making sure that we have genuine expertise, HPC expertise in the teams planning and building, designing and deploying the infrastructure, and the teams interacting with the customers, whether that's in a architecture mode or pre-sales technical support mode or the salesperson, or indeed in the post-sales support mode. So we have a dedicated HPC and AI support team, 24/7 support globally, just dedicated to our HPC customers and our AI customers. So that's a pretty unique capability as well. We're also focused on behaving like a true supercomputing vendor. And that we are making sure we are bringing the appropriate technologies, so key new processors and key new interconnects and so on, into the market as early as anyone else, and in many cases before anyone else. So this idea of Azure being the first place you can get access to new technologies. So as an example of that, when AMD launched their Milan processor last year, on the day that AMD launched the processor, Microsoft Azure had the clusters up and running around the world in multiple locations with AMD Milan processors with InfiniBand interconnect And they were available for the public to use in general availability mode on the same day AMD announced general availability of their processor. And that was, you couldn't get the processor anywhere else other than Azure. And then it took the on-prem providers a little time to catch up with us, and then it took other cloud providers many months to catch up with us. And that's a theme that's going to see going forward for how Microsoft approaches the HPC market. Will identify the key technologies that are significant steps forward in performance or price performance or features or capabilities, and we're going to try and focus on making sure they're available in Microsoft before anywhere else. It's also important to recognize that we're building the infrastructure because it's purpose-built for HPC. So as I said, we're not taking an existing cloud infrastructure and figuring out how to do HPC on it. We're purpose-building the infrastructure top to bottom, from everything from the data center all the way up through the hardware infrastructure to the software infrastructure. For HPC, that means we're able to design infrastructure that's focused not only on delivering the best performance and the best scalability, but also the best price performance, particularly the best price performance against the real application workloads. So what's the best total cost to solution, rather than focusing on intermediate metrics like cost per core? So what's the cost of delivering the user's workload? And making sure we give them the best answer to that. The other thing we're doing is trying to figure out how to partner with our customers for the long term to solve the HPC needs, understand what the actual business requirements are, what the user requirements are, what's the science problem they're trying to solve, what's the business problem they're trying to solve, and how we can work with customers to partner to solve those problems together rather than just sell cloud. And so onwards to the first of our 4 supercomputer stories. So in April 2021, it was announced that Microsoft was going to deploy 4 supercomputers for the UK Met Office. This is part of a 10-year managed supercomputing service that we competed for and won as part of a formal competitive procurement exercise. The procurement exercise was for a managed supercomputing service, not for cloud specifically. And it was Microsoft Azure's unique approach to HPC in the cloud that we've been talking about in the previous slide that enabled us to bid against a managed service requirement, or managed supercomputing service requirement, rather than specifically a cloud requirement. And those 4 supercomputers will be the first generation of this service. So generation 1 runs for the first 5 years, and then there's a generation 2 which runs for the second 5 years. So those first 5 years generation will be based on these 4 supercomputers deployed. And the reason it's split into 4 is for operational resiliency reasons and so on. And then later in the same year, in June, we come to our second 4 supercomputer story. And this is where Microsoft listed 4 of our supercomputers in the top 30 of the top 500 list. And this is important for a number of reasons. First of all, as far as I'm aware, it is the first time that any cloud provider has listed permanent, genuine supercomputers on the top 500 list. So there's been cloud providers who've listed a number of non-HPC clusters, or certainly non-supercomputers. There have been some quite important work by not only other cloud providers, but other customers of other cloud providers who have configured and deployed virtual clusters on the cloud infrastructure, stood up to run the LIMPAC benchmark, or stood up to do real work, but then run the LIMPAC benchmark on it. But those are still virtual infrastructure. So as far as I know, this is the first time any cloud provider has listed the actual physical supercomputers that are underneath that and that are deploying the infrastructure. This was not run on the full-size clusters, and this was run on a portion of the clusters. And we listed 4 of them in the top 500. We actually went a step further in November. So we took one of those 4 clusters. I should add that we have more than 4 such clusters. We just chose to list 4 of them, or chose to run the benchmark on 4 of them, and therefore list 4 of them. We took one of those clusters in November for the second iteration of the top 500 list in 2021, and ran the LIMPAC benchmark on a bigger fraction of the cluster, still not the full cluster, and achieved the number 10 spot with a 30 petaflops Rmax score. And these public community benchmark proof points are illustrative of how Microsoft is going about designing our supercomputing infrastructure, demonstrating our supercomputing infrastructure, and engaging with the community. We're doing it in the way that the community has been used to doing it for a long time. We're doing it the way any other supercomputer center would do it. We're doing it the way any other supercomputing vendor would do it. So over the last 2 or 3 years, we've been deliberately achieving and talking about achieving, or publishing, if you like, sharing with the community, a number of achievements that are typical of supercomputing achievements. So things like showing the scalability of MPI jobs across our infrastructure, being the first to deploy or deploying InfiniBand clusters, for example, and benchmarking those against other InfiniBand clusters in the community, being the first to deploy a particular generation of InfiniBand anywhere, on-prem or cloud, scaling the jobs up even higher in terms of MPI cores, deploying a system that was that's comparable to top 5 supercomputers in the world in terms of scale and performance. In other words, if we ran Limpac on it, it would get a top 5 score. We deployed that supercomputer for OpenAI. It's not necessarily the only large-scale supercomputer we've deployed. And then there's other achievements over time. Parallel file system performances. I've already talked about the getting time to market with the Milan GA in Azure. We talked about the supercomputing service for the Met Office. We've talked about the top 500 results, and we're doing the same in other spheres as well. So, we scored the #1 cloud score in the MLPerf benchmark, which is heading towards being a community benchmark for the machine learning community. So this continuous cadence of proof points around the infrastructure, demonstrating Azure's leadership in cloud HPC. But it's not just about the technology, it's not just about the infrastructure. Importantly, it's also about the applications and the real workloads. And as I said before, this is what's driving the design points for our infrastructure. Designed around specific application workloads. They're designed and measured and tested using those application workloads, and therefore they're demonstrated to the community, either using these well-known applications in the community, or indeed using a specific customer's application when a customer's talking to us about their users and their needs and their requirements. And so there's a range of real applications shown here, from computational fluid dynamics to weather modeling to molecular dynamics and other things as well. And that means that we're able to design infrastructure to achieve this and to demonstrate to our customers that we have the best application scaling in the cloud. We have the best performance per virtual machine or per node. We have the best overall performance per dollar for the application workload. We can see some data there showing the highest core counts that we've achieved for various applications, which is both genuinely useful data showing the scaling ability infrastructure, that it works and that customers are able to scale up to that, and also simultaneously being a bit of marketing fluff, to be honest. But it's a strange thing of being both useful and not necessarily illustrative at the same time, because of course what really matters is how your particular workload performs on the infrastructure and how well that works out with the scalability, the performance, the economics, and so on. But these are indicators of what's possible. And so there's a number of different reasons that customers choose Azure for their HPC and AI needs. And various versions of this chart over time have had great big long lists of reasons or lists of anecdotes that customers have told us about why they chose Azure. And almost all of them come down really to some variation on the story that's on the page there. The use of Azure allows customers to reduce the risk of predicting and adapting to technology. Because Microsoft is doing a lot of research into the technology, figuring out the roadmaps of the future, deploying and testing multiple versions of those roadmaps, which is something most customers can't afford to do, is to actually bet on multiple instances. We deploy multiple different technologies, which means that customers can try different things and adapt and evolve over time to evolve as their application needs evolve, as their business needs evolve, as the users evolve, to adapt to take on the performance advantages of new technologies or of business growth or scale growth or whatever. And so really by working with Azure with this range of capabilities and the fact that we're always continuing adding new capabilities, it removes the need for a customer to try and figure out on day one of a 5-year cluster life exactly what their AI focus versus HPC focus, or their CPU needs versus GPU needs, or their compute versus storage needs are going to be for the next 5 years and lock them in on day one. So working with Azure essentially gives that agility back to the customer, both in terms of technology agility, but also financial and business agility. Technical agility, being able to jump to and adapt to whatever technologies we bring out or the market brings out that we tend to implement over the next 5 years, but also the financial agility or the business agility to be able to change the scale of your infrastructure or the focus of where your spending is going over the 5 years. One of the downsides of the cloud that you will hear all of the major cloud providers say or do or brag is how many different instances we have, how many different virtual machine types we have, or how many different services and technologies we have. I'm sure Azure has a slide somewhere that lists how many hundreds of virtual machines we've got and how many hundreds of services we've got and so on. Everybody does this. And that's good, because that's one of the advantages of moving to the cloud infrastructure, is that breadth of capabilities that are available. So almost anything you want to try is there, and even things that you didn't think you wanted on day one. Once you've got, say, a stable application up and running, there are then opportunities to augment that with new capabilities you hadn't envisaged on day one, whether that's adding machine learning into your compute infrastructure, or adding microservices, or looking at ways to deploy the results to an external community, for example. The counter to that, of course, is complexity, or surplus of choice, or however you want to phrase it. And that is one of the challenges that we have in the cloud, is battling the complexity, because we're offering so much, is how to offer, how to provide an easy path through all of that. I think it's something that, frankly, all other cloud companies need to figure out and evolve and get better at over time. But we're doing that through tools, and everybody will have a story around this. This is Azure's story. We have a series of standard tools and technologies that you would expect to find in a HPC environment that help to manage that complexity, help to find the path through it, and help to deploy the right infrastructure for your business. So standard job schedulers. We can provide job schedulers. We also interface with all of the, or most of the standard job schedulers expect from the HPC community. Workflow managers, container solutions, adding AI toolkits, prepackaged solutions for AI toolkits, and so on. We've talked about the infrastructure already. There's also stuff that we put into place around the clarity and control and governance of the infrastructure. So things like cost reporting and cost controls, monitoring of the infrastructure, traceability. Security is a key factor in all of that as well. Providing access to Microsoft's however many thousand security engineers we've got looking after our infrastructure. And essentially it's about delivering this overall end-to-end experience. So the high quality platform, the world-class support that I mentioned previously, focused or dedicated to HPC and AI customers and workloads, comprehensive training, both publicly available and privately available, community engagement and ecosystem development. These are really significant things. A strong part of Microsoft's ethos in the world is not competing with our customers in the Azure HPC and AI space, and trying to focus on how we can help partners in that ecosystem to have a viable role in delivering their expertise to help our mutual customers achieve more and unlock their innovation. So with working with customers and working with partners to help those customers. And there's two sides to the way you can orchestrate your workloads on HPC and AI. So there's Azure Batch, which is something like a HPC as a service model now. There's a whole load of discussion about the semantics of whether it's a true HPC as a service or not. But as a first approximation, it's a way to essentially turn up and use a cloud native computing environment and bring your workloads to the environment. You don't have to worry about managing or operating or designing or configuring a cluster. You just throw your workloads onto Azure Batch and it scales as necessary and runs your workloads and send them back. I simplify for the sake of presentation, but that's the concept behind it. And then the other side, or the other way to do it, is through building a virtual cluster infrastructure that is very similar to what you would have on premises. It's just that it happens to be virtualized. And Azure Cycle Cloud is the tool for doing this. It's one of the oldest and most established tools in the industry for doing this, where you can configure and build a cluster virtually that is either very close to your traditional on-prem environment, so you can lift and shift, you can port or migrate your workloads from an on-prem environment to the cloud environment, or you can do things like bursting or hybrid cloud computing and so on. And again, this can build in things like dynamic scaling of the cluster infrastructure and so on. It's actually part of a change in the industry as a whole over the last, I guess, decade or so, maybe a little bit longer, depending upon which part of this chart you're talking about, where the HPC business as a whole, or the HPC community as a whole, is evolving in maturity. So it's quite common now to talk about HPC services rather than just HPC hardware. So rather than talking about a high-performance computer, mostly we talk about high-performance computing now, what you do with the infrastructure, how you deploy the infrastructure and then build a service around it to your users and your customers. In fact, we even see some organizations who are using HPC in an on-premises environment talking about having a HPC product manager managing the product that is HPC to their internal customers, rather than necessarily an IT sysadmin lead or an HPC sysadmin lead or a HPC service director, for example. The idea of building a product which is HPC that you're serving to users. So there's a growing focus around other things like metrics, finding the right metrics to measure and the right metrics to report on your HPC environment, how it's delivering value to the business and how operationally efficient it is. And they may well be, in fact, they almost certainly should be, different metrics for measuring operational efficiency versus measuring impact and value to the business. And then other things like building total cost of ownership models, and then evolving from that to total cost of solution models, and then looking at things like value models and cost models and risk models and how they combine together for how your business is using HPC. When I first started delivering tutorials on this stuff, probably nearly a decade ago, about a decade ago, there was hardly any of this going on. There were a few places doing it, but it was not common and widespread in the community. Now it's pretty normal to go into a HPC environment and find that there is a total cost of ownership model or even a total cost of solution model. And in some cases, that extra step further of value and risk and cost models. So there's a growing professionalism across our industry, which again influences the kind of HPC environment we have to build and deploy and how we have to interact with our users and our customers. Across all of that, by focusing on the business processes, focusing on the user experience, focusing on building a genuine HPC infrastructure and the software infrastructure around it and the people interactions around it, we are demonstrating, and customers are telling us, that Azure is enabling significant value for those who can adapt to using a genuine HPC integrated with a cloud environment, in other words, the Azure solution. Our business is strong and vibrant and growing with this very strong vision to the future, such that we have a significant number of opportunities open, with more coming. In fact, this chart is out of date, so I looked again today for another reason. It's actually over 85 opportunities, I think, now 86 opportunities. So we have a large number of HPC roles open across the organization from all sorts of different roles: software engineers, hardware engineers, developers, product management, program management, business development, sales, user support, marketing, all sorts of different opportunities to help out and get involved and join our team. If you do that, you come and join a fun team, an ambitious team, a passionate group. We support each other. You work on building future generations, plural, of AI and HPC supercomputers within Azure, creating a truly transformative experience for the industry as a whole, and of course for our customers, and help to unleash our customers' to work on some of humanity's most pressing science and business challenges. So if that sounds exciting to you, please do get in touch. With that, I'd like to close and thank you very much for your attention, and hope you enjoy the rest of the conference. Thank you very much.